When you're talking about a multi-million-dollar industrial coating project, it can literally succeed or fail based on one thing, that very first step, getting the initial condition assessment right. It's not just important, it's everything. So let's get into why this foundation is so critical.
And this quote right here, it really hits the nail on the head. Look, no coating lasts forever. We all know that. But the ones that fail way too early, the ones that cost a fortune in rework and downtime, almost every single time, you can trace that failure back to a problem that was missed right at the beginning. The good news, though, that means these huge, costly failures are almost entirely preventable.
All right, so here's our game plan for today. We're going to start with the why coatings fail. Then we'll cover the inspector's mission, what their job really is. After that, we'll get into the nitty-gritty, spotting defects, grading rust, and uncovering those nasty contaminants. And finally, we'll wrap it all up to show how this all builds a real foundation for success. So let's jump right in. At the end of the day, how long a coating lasts, whether it's 5 years or 25, it's got way more to do with the quality of the surface prep than pretty much anything else. This is where the battle for a long service life is either won or lost. And it really all comes down to these three things. Think of it like a three-legged stool. First, you've got to remove contaminants, because if you don't, you're just asking for blisters. Second, you have to hit that specified level of cleanliness. If not, the coating just won't stick, period. And third, you need to create the right surface profile, that texture or roughness, so the coating has something to actually grab onto. You miss any one of those legs, and the whole system just comes crashing down. So, who's the person on site guarding these three critical goals? Well, that's where the coatings inspector comes in. Their whole mission is to be the expert eyes and ears on that job site, making sure that steel substrate is the perfect canvas before a single drop of paint even gets near it. Now, this is a really important point. The inspector's primary responsibility is to verify conformance. And I'm stressing that word verify for a reason. An inspector isn't there to rewrite the project spec or tell the crew how to do their jobs. Their role is to observe, to test, and to confirm that the work being done meets the exact requirements laid out in the contract. They're the quality control checkpoint, plain and simple.
And this slide breaks down their process perfectly. It's a simple but really powerful loop. You observe the conditions, you run the required tests, you verify that the work meets the spec, and, this is huge, you document everything. Every single observation, every test result, it all goes into the daily report. That creates a bulletproof record of compliance. Okay, let's get into the inspector's first real task when they get to a site, that initial visual assessment. I'm talking before any blasting or cleaning even begins. You gotta walk the site and identify any flaws in the steel itself that could cause major headaches down the road. And you're basically on the hunt for stuff like this. You've got mill scale, sharp corners and edges, really rough welds, weld spatter. Those are all the usual suspects. But then you also have things like inclusions, which can create these hidden weak points. Every single one of these flaws can compromise the final coating, so they all have to be identified and fixed before the main surface prep kicks off. Here's a perfect example. What you're looking at is surface lamination. It's an imperfection from when the steel was actually made. If you just paint right over that, that little piece is eventually going to pop off, and it'll take your brand new coating right along with it. So the inspector has to flag it, and it's got to be ground down to solid steel. And here's another one to watch out for. Inclusions. These are basically little bits of non-metallic gunk that got trapped in the steel when it was molten. Just like laminations, they create a weak spot, so you guessed it, they have to be chipped or ground out to make sure that coating is going onto a solid, uniform surface. All right, so once we've spotted all the physical defects, the next job is to classify the corrosion that's already there. And we can't just write down it's rusty. We need a precise, standardized language for it so everyone is on the same page. And here's a quick but really important point. Depending on the spec you're working from, you're going to see one of two terms. SSPC standards call it initial condition, while the ISO standards call it rust grade. They mean the exact same thing, so don't let the different wording throw you. It's just two names for the same concept. So how do we make this assessment objective and not just a guess? Well, inspectors use these standardized visual guides. These books have super high-quality photos of the different rust grades. The process is pretty straightforward. You hold the guide right up to the steel on the job site, and you find the picture that's the closest match. It totally takes the guesswork out of the equation. And that comparison gives you a simple code, usually A, B, C, or D. So for instance, rust grade B describes steel that's starting to rust and where the mill scale has begun to flake off.
That grade gets documented in the daily report, and it sets the baseline for just how much cleaning needs to be done.
Okay, so we've assessed the steel itself. Now we have to deal with all the stuff that's sitting on top of it. You see, contaminants are a coating's absolute worst enemy, and our job is to find all of them, both the ones you can see and, more importantly, the ones you can't. We always start with the obvious stuff. Standards like SSPC SP1 are super clear about this. All visible junk like oil, grease, dirt, even cement splatter. It all has to be removed before any abrasive blasting happens. We call this pre-cleaning, and it's critical because if you don't do it, the blasting process can just smear that contamination all over the entire surface. But this is where the job gets really tricky. Getting rid of the dirt you can see is one thing, but some of the most catastrophic failures come from enemies that are completely invisible to the naked eye. I'm talking about soluble salts, things like chlorides, sulfates, and nitrates. These are microscopic chemical compounds that can get on steel from things like marine air or industrial pollution. If you coat over them, they act like tiny little sponges, literally pulling moisture from the air right through the coating felt. And that leads to massive blistering and corrosion that just rips the coating off from underneath.
So, how in the world do we find these invisible threats? We test for them. After blasting, an inspector will do a salt contamination test, often using something like a Bresle Patch Kit. It basically involves putting a patch on the surface to pull out any salts, and then you measure what you found with a conductivity meter. If the reading is too high, everything stops. This is an absolutely critical inspection hold point.
Okay, so let's recap. We've identified physical defects, we've graded the rust, and we've tested for contaminants, both visible and invisible. So let's bring this all home and remember what the ultimate goal of this entire process really is. Everything we've just talked about, spotting those defects, grading the rust, hunting for contaminants, it all serves to accomplish three simple but absolutely critical goals. And there they are again. The entire purpose of this detailed, meticulous assessment is to guarantee that the final prepared surface is totally free of contaminants, meets the cleanliness standard from the spec, and has that perfect surface profile so the new coating can grab on tight and last for decades. That's the whole shebang right there. So by observing, testing, verifying, and documenting, the inspector has confirmed that this foundation is rock solid. The substrate is clean, it's graded, and it's documented. It is finally ready for its protective shield. But what happens next? Well, that's a story for another day.